Good morning, everybody. Okay, so fact of the day today. It's our last fact in the 5 times table. So let's go out on a bang. So this is 12 times 5 equals, I haven't given it to you, 5 times 12 equals, and then whatever that number is divided by 5 equals 12, that number divided by 12 equals 5, and then we've got some mega facts up the top. So can you solve these four? Solve these mega facts, think of as many others as you can, and if you want to represent it in some different ways, wow, that was a lot of stars, that took me a lot of stars to do. Can you represent the fact of the day? Okay, look forward to having a little look at that on Zoom later. So, for our main part of the lesson today, RTLP is, can I record fractions using numerators and denominators? Now, for this section, I would like you to find your 10 counters, which you should have had in your last pack, or one of the previous packs. If you haven't got those, if you can find some counters, we can make those work as well. But if you've got 10 of these red and blue counters, we call them, that would be perfect. If you've also got a red and blue, either pencil or pen, that would also be great. So if you can find those things, and then we can make a start. Right, now, the first thing you might be thinking is, oh, these are very long and slightly complicated names. I wonder what they mean. So this is a fraction we should all know really well. It's half. It's half. If I said I would like half of the cake, I would get my cake and cut it into 2 equal bits. That would give me half. Oh, I've made my cake appear as if by magic. So as we learned with our fair feast yesterday, to cut it in half, you have to make sure it's exactly the same on both sides. I can't be a meanie and cut my cake here and give one part to my son and one part to keep for myself, because that's not halves, is it? It's not fair. So one of the things about fractions is they have to be fair, they have to be the same. So I'm going to take my cake, my whole cake, and I'm going to cut it into 2 equal parts. Okay, that is my denominator. So this is 2 equal parts, that's my denominator. Now, to show this fraction, I only need one of those halves. So I'm going to keep my other half over here. So this is 1 half, 1 part of 2 equal parts. This numerator is the number of parts I'm talking about, and the denominator is how many parts there are altogether, how many there were to start with. So numerator and denominator. Okay, let's think about counters. If I have 2 counters, one is red, there are 2 counters, one is red, one is blue, I would say half of my counters are red. And also, of course, half of my counters are blue. I've got 2 counters and one of them is red. So we've got the numerator up here and the denominator down here. So let's think about a different fraction. This time I'm looking at 3/4. When you divide something into 4 equal parts, when the denominator is 4, we call that quarters. So 3/4 of a cake. Okay, so at the minute my cake is only in halves. I'm going to split it into quarters. Now, my quarters are fair. My quarters are fair, but I'm thinking that I might have 3 of the quarters. So let me take those out. 1, 2, 3. And leave 1/4 for Mrs. Joshi. So actually, fractions can be unfair, but it is fair that I've split it into 4 exactly equal parts. It's hard to hold them up. Okay, so this fraction here is 3/4 of a cake. I'm getting more than half. I'm getting 3/4. So, how would you show 3/4 of the counters are red? I'm going to just pause for a minute. How many counters do I need altogether? and how many will be red? Well, if you've shown it like this, you'd be right. I need 4 counters all together. I'll make them all red to start with. So these are my quarters, but I need 3 of them to be red. So 1 of them has to be blue. I'm going to put them on there actually so you can see them all. So this time, 3 quarters of my counters are red. I might even put them into a square to show you really clearly. So 3 quarters of my counters are red. The numerator, the number of counters I'm talking about, is 3. The denominator, how many altogether? 1, 2, 3, 4. I wonder if you can tell me how many, what fraction of my counters are blue? If you said 1/4 of my counters are blue, you'd be absolutely right, because this time the numerator, the number of fractions I'm talking about, is 1, and the denominator is how many bits there are altogether, how many counters altogether. So 1/4 are blue, or is blue, because there's only 1. 3/4 of my counters are red. Can you show me what 1/4 of the cake would look like? That's right. Poor old Mrs. Joshi is only getting 1/4 of the cake. What a meanie I am. Okay, so on to our game. First of all, we're just going to start with 4 counters. Now, if you have somebody to play this game with, that would be brilliant, but you can play it on your own if you don't have anyone to play with. So what you're going to do, easy peasy to start with, you're going to start with your 4 counters, okay? And all you're going to do is toss them up in the air. Try and keep them quite close. Now, let me arrange them. Oh, it's very similar to the one I've just done. So in my red pen, I'm going to show what fraction of my counters are red. So I know I've got 1 red counter, and altogether my denominator, 1, 2, 3, 4, is 4. So I've got 1/4 is red, and that's why I'm using my red pen. So now you can see why I needed that. But if I was the blue player, I've got 3 blue counters, and my denominator, of course, 1, 2, 3, 4, is still 4. Now, what people always do when they're starting out with this is they put 3 over 1, because they say, right, 3 are blue and there's 1 more, 1 is red, so I'm going to put 1 at the bottom. But as we know, the denominator means how many parts are there altogether. So you have to include the ones you've already counted and add on any others that you haven't counted. So we've got 1/4 and we've got 3/4. Now, who's won? Who's got more? Who's got the bigger fraction of the counters? Well, this time it's blue. So I'm going to put a tick next to blue because they are the winner. If you're being really fancy, you can use your greater than and less than signs. So 1/4 is less than 3/4. 1/4 is less than 3/4. Doesn't matter what colour you do that sign in, it's absolutely fine. Right, throw up in the air again. Ah, now blue is definitely the winner this time, isn't it? Okay, so the challenge is, how are we going to write the red fraction? Okay, now we know that the denominator is still 4. There are still 4 altogether, but how many are red? That's right, it's 0. So there are 0/4 that are red. Okay. Now again, I always think really it's best to start with the denominator, because then you don't forget what that number should be. Again, we're talking about quarters because there are 4 counters. How many of them are blue? 4. And of course, another way to say that is 1 whole. All of the counters, the whole group of counters is blue, or are blue. The whole group of counters is blue. all the counters are blue. So you can also write that fraction as 1. So I'm going to, actually I won't do that because I don't want to confuse anyone, but you need to know that as well. And of course 0 quarters is the same as saying 0, nothing. Easy peasy. 0 quarters is less than 4 quarters. Right, one more. And then we're going to try with some bigger numbers. Oh, how funny. What are the odds of that happening? So again, we know the denominator is 4, and I might even put it in for the blue one as well. How many out of 4 are red? That's exactly right. 4 quarters are red. Can you remember how else we say that? That's right, 4 quarters is 1 whole. If I ate 4 quarters of the cake, I'd be eating the whole cake, wouldn't I? Poor Mrs. Joshie wouldn't get anything. So, of course, now we have to fill in the numerator for blue counters. How many of my counters are blue this time? It's 0. So, 4 quarters are greater than 0 quarters. So this time, I need to put my symbol the other way round because this is the greater number. It is the larger number. So 4 quarters are larger than 0 quarters, of course. Absolutely. Right. Now, to challenge yourself, you might want to extend your number of counters. This time, I'm going to do 8. And the reason I've chosen 8 is because it's just doubling up on the quarters, isn't it? Okay, so at the minute, I would say that my blues are 2 out of 1, 2, 3, 4, 5, 6, 7, 8. So if it was like a spelling test, I'd say I got 2 out of 8. And for my red counters, I'd say 1, 2, 3, 4, 5, 6 out of 1, 2, 3, 4, 5, 6, 7, 8. So 6 eighths versus 2 eighths. So of course, for this one, red would win. But that's not part of my game. That's just where they landed. Right, let's play the game. Okay, let me arrange them. Oh, isn't that typical? Look, it's done it exactly as I said. Okay, how funny. Right, so again, it's always going to be, when I've got 8 counters, my denominator is always going to be 8. I haven't lost any of the counters, none of them are going away. There's always going to be 8 counters when I'm playing with that number. So we know that 6 of the eighths are red. So 1, 2, 3, 4, 5, 6. 6 eighths are red. How many eighths are blue? That's right, 2 eighths are blue. So who's won this time? Who's got the most? That's right. 6 eighths are greater than 2 eighths. Right, I'm hoping for a different one this time. If I don't get a different one, I will have to have another go, I think. Oops, I have lost one off the table, but that's okay. Okay, that is, oh, thank goodness for that. That is a red, so I have got a different one this time. Now, just looking at it, who do you think's won this time? Who's got more? What's the larger fraction, red or blue? Right, let's make them nice and neat. You know I like things when they're nice and neat. Oh, there we go. Oh, I prefer it that way. There we go, that does look neat. Brilliant. If you said the blues have won this time, you'd be absolutely right. Blues are the bigger fraction. So again, I'm going to put blue eighths and red eighths. Okay, we might even play this game on Zoom later if I can do it properly. So, I've got my blue pen, so I'll start with my blue. So what is the numerator for the blue fraction? I've already got my denominator is 8 because I've got 8 counters all together. How many of them are blue? What is the numerator? If you said 5, that's exactly right. Well done. What is the numerator for the red counters? 1, 2, 3. 3. So 3 eighths of my counters are red. 5 eighths are blue. So the bigger fraction is this one. So 3 eighths are less than 5 eighths. Okay, so you can play that game, you can change the number of counters, but do remember when you change that number of counters, the denominator is going to be different, but always the same in the same number sentence. You could even, if you're feeling fancy, build up to having all 10 of your counters, and there the denominator would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for example, if you threw this pattern, we would have 10 counters altogether, but it would be exactly equal. Okay, right, have a go at playing this either on your own or with a partner. We look forward to seeing you later.